Hi there, it's Jason Gorman from Codemanship here with the second part of the 5th tutorial in our series on test-driven development in C#. In the first part of this tutorial we looked at inside-out test-driven development, where you saw me test drive individual pieces of the internal implementation design, if you like, for our Mars rover, and then I put those pieces together like a jigsaw at the end, and we discussed the relative advantages and disadvantages of that approach. The main advantage being that when our tests are testing specific pieces of the internal design, then that very precisely pinpoints the sources of errors when things go wrong, when our tests fail. But it had the disadvantage of exposing a lot more of the internal detail, a lot more of the implementation design to the test code, which means that our implementations will be difficult to change going forward because of all the test code that would need to be changed. And also there's a risk when we test drive pieces of the jigsaw, that when we try to put the jigsaw together at the end, the pieces don't fit. So in this second part, we're going to look at approaching it from the outside in. And I've already made a start on our Mars rover. It's the same test cases as you can see, so there's still meaningful tests about turning the rover right and turning the rover left. But you'll notice that inside the test code, rather than calling an internal method called right or an internal method called left in our rover, I'm actually just going through the external interface, going through this go method that accepts sequences of instructions to drive our rover, to turn our rover. These tests are all passing. And if we take a look inside our rover, you'll see what I've got so far. Inside my go method is an if statement with a couple of options here. It's either right or left, and if it's right, then we turn our rover clockwise in terms of the compass, north, east, south, west. And if we're turning it left, we turn it the other way around, anti-clockwise, so we go north, west, south, and east. So straightforward at the moment. We've got tests passing, so I'm thinking at this point about whether I should do some refactoring. And there's a bit of duplication in here. Now, you'll recall in the third video we talked about, the fourth video, we talked about duplication and the rule of 3, that we need to see 3 examples of duplication before we remove it. But if you recall, I did say that that was kind of a rule of thumb. It's not a hard and fast limit. You must have 3 examples. In this case, we've got 2 examples of duplication, and I think because we're only going to have right and left, we can only turn one way or the other. I think at this point I can see what the pattern is going to be. So I'm actually going to refactor this duplication and see what kind of design we end up with. So let's start with these 2 lines of code in both blocks here are exactly the same pretty much. So let's extract that into its own method. And let's call that turn. So it'll turn in whichever way the compass is oriented, whether it's clockwise or anti-clockwise. Okay. Let me just rerun my test immediately to make sure that nothing is broken. And we can reuse turn here. And immediately rerun all my tests. And since the parameter is called compass, I don't think having a local variable called compass is really adding anything in terms of documentation. So let's inline these. I think it's fairly safe to do them both at the same time. And again, immediately rerun our tests. Okay, and I think we can make this a little more self-documenting. So this means turn right. So let's extract a method for turning right. Okay. Let's run our tests. And this means turn left. So again, we extract a method to document what this piece of code does. A very, very valuable use of methods and functions is to essentially document code. So this is left. Let's rerun our tests. So we can begin to see that an internal design is emerging from this go method. So as we were refactoring our code, removing duplication, making the code self-describing, an internal design is beginning to emerge. There's a bit of a call stack starting to form here. And this is the essence of outside-in TDD. We start at the external interface. We'll talk in the next video about why it might not be an external interface necessarily. But in this example, we start with our external interface for the rover, which is just this go method. And then these private internal details start to emerge through the process of refactoring that internal design. And what we're beginning to end up here looks very, very similar to what we had before when I did it inside out. But the advantage of doing it this way, we talk a little bit about when you do it inside out, essentially you're test driving the pieces of the jigsaw and then trying to put the jigsaw together at the end. In the outside in approach, we make the whole jigsaw and then we cut it into pieces, which means those pieces are guaranteed to fit. You will also see that the left and right functions are private. They're encapsulated. They're hidden behind this go method. So our test code doesn't need to know about them. So our test code is less coupled to the details of the implementation. So that's one really big advantage of working outside in. So with outside in, we have two advantages here. We have the big advantage that we end up with all the pieces fitting. We're guaranteed that they will fit because we're essentially extracting those pieces as we refactor and running our test to make sure that we're still delivering what the end customer wants. And also we end up with test code that knows less about the internal implementation design, and therefore it's going to be easier going forward to refactor that internal design, evolve it and adapt it as necessary because our tests are not so closely coupled to it. So that's outside in design. What I'm going to do now is I'm going to fast forward to the finished version of this outside in, and we'll take one little look at that. And then we'll summarize inside out versus outside in. So just going to pause the video for a second here. So what we have at the end here is essentially the same set of tests, but they're all written just using the rover's go method. So that's all our test code really knows about. The rover is the constructor, the go method, and how to get the direction it's facing and its positioning. And if we take a look inside our rover, we can see now that a lot of the methods are now private. There's a lot less known, there's a lot less exposed. So rover is much better encapsulated, and that's one of the advantages of working from the outside in. So that's outside in TDD. Remember, the two advantages are, one, you end up pretty much guaranteeing that the pieces of the jigsaw will fit because you're extracting those pieces by refactoring the internal design. And you end up with test code that is much more loosely coupled. It knows a lot less about the implementation, and therefore the implementation is going to be much easier to change going forward. The disadvantage is if any of our tests fail, we're only entering at this level, so we have to go digging down into the call stack to figure out exactly which part of our rover went wrong. Now, for this amount of code, that's not really a problem. That will be absolutely fine. But as our applications become more complex and we get more and more layers in our design, then this does become a problem. It can become quite a serious problem when our tests are too many degrees removed from the code that they're testing. And then we end up back in the debugger tracing back through the call stack to figure out where it's gone wrong. So the disadvantage of outside in for more complex designs is that these kinds of tests are not as good at pinpointing the sources of errors. So Inside-out TDD, really good for writing tests that pinpoint the sources of errors, but your test code tends to be more tightly coupled to the implementation and therefore harder to change in the implementation. And also there's the risk that the pieces of the jigsaw don't fit when you try to put them together. Outside in is great for guaranteeing that you end up with the pieces of the jigsaw that will fit, because you're driving them directly from what the end user wants and then refactoring to extract those pieces. And you end up with test code that is much more loosely coupled, that knows a lot less about the implementation design, but has the drawback as we add more and more layers to our code, essentially, with more complex architectures, that they're not very good at pinpointing the sources of failures, and then we end up back in the debugger. Now, in the final video in this series, we're going to be looking at how we can have our cake and eat it here by approaching design from the outside in, but also at probably a more granular level than individual methods and individual classes, but have tests that still help us to pinpoint where things have gone wrong. So how do we have our cake and eat it? So in the final video, we'll be talking about outside in TDD using stubs and mocks.